Okay guys, so I'm going to go over the interim study guide, and I'm going to do numbers pages 3 and 4. Alright, so let's go over some of these exponent rules. So I'm going to show you some calculator ways and some non-calculator ways. I'm going to grab the calculator. Which one, and pay attention to questions like which one is false. That means 3 of these are correct, okay? So for example, this is going to be true because you add the exponents, but if you're not sure, you can always check. So like for example, answer choice A. 2 to the 5th, remember 2xy fifth equals 32, then times 2 to the 12th equals 131,072. So does that equal the other side? So let's see. Does it equal 2 to the 17th? So 2 to the 17th equals, yep, exactly the same number. So that's true. Okay? So we don't want that one because we want one that's false. Okay, so let's try B. 2 to the 14th over 2 to the 20th. Well, if you write it all out, it would be 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Make sure you have the exact. Then you'll have 16. 1, 2, 3, 20. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think I got it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Got one too many. Okay, so then cross out all the ones that are paired up. They come out to be 1. And you got nothing left up here, so it's 1 over 1, 2, 3, 4, 5, 6, 2 to the 6th, which is what we have here. Another way to check it is just divide. So 2 to the 14th divided by 2 to the 20th, 2 to the 14th divided by 2 to the 20th equals 0.015625. Well, let's see if that's the same as 1 divided by 2 to the 6th. So 1 divided by 2 to the 6th. And that gives you the same one, so that means it's true, which is what we don't want, because we're looking for what's false. Okay, let's see if this is true. 2 to the 4th to the 5th, is that equal to 2 to the 20th? And what we know is yes, the exponents do multiply. But let's see if that's true. So let's see. 2 to the 4th, 2 to the power of 4 equals 16, and now take that to the power of 5. And that's 1,048,576. So we can write that. 1,048,576. Now let's see if it equals the other side, to the 20th. 2 to the power of E is the same thing, so C is false. C is true. Let's see if D is false. Well, yeah, this is, okay, so what you can do is check it. So 2 to the power of negative 3 equals 0.0 or 0.125. Does that equal negative 2 to the 3rd? So you got to do 2 to the power of 3 first, which is an 8. Then make it negative. These are not the same. Okay, they're not the same numbers, so therefore D is false. Be careful. The trick is, do you know what a negative exponent means versus a negative base? Number 2. What is 3 to the negative 4 in standard form? Well, remember, 3 to the negative 4 is 1 over 3 to the positive 4. Okay, so that's going to be 1 over 3 times 3 times 3 times 3. Remember, the reason is because the negative flips down to the bottom. Okay, so then you got 3 times 3 times 3 times 3, which is 81. So be careful, this is a trap, because that's if it's just 3 to the positive 4. Okay, but we want 3 to the negative 4, which flips it to the bottom. This is another trap, which is answer choice A, because a negative exponent doesn't make a negative number. Okay, and this one is probably a trap for those of you that accidentally think you just take the 3 and multiply with the 4. So this is the correct answer. Now, let's say you forgot this, then you can use your calculator. 3 power of negative 4 should give you this long decimal. Ooh, look at that. 1, 2, 3, 4, 5, 6, 7, 9. Interesting. Then 1 divided by 81 should give you that exact same one. So let's do it. 1 divided by 81, same decimal. So number 2 has to be correct. Number 3, what is 8 to the 4th times 8 to the 12th in exponential form? Well, you're supposed to add, but let's say you weren't remembering how to do that. So 8 to the 4th means 8 times 8 times 8 times 8. This means another times, and then you got 12 more. 1, 2, 3, 4. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. But that's just 12 plus 4, 8, so it's 8 to the 16th, okay? So it should be this one. Now let's see if that matches. So if you do 8 to the power 4 times 8 to the power 12, it's going to be a huge number. Okay, so this looking number, okay, this is now going into scientific notation. Well, let's see if 8 to the 16th gives us that. It does. Oh, no, it doesn't. Hold on. What was it? 8 to the 4th, 8 to the 4th power times 8 to the 12th power equals. Oh, 8 to the 16th? 8 to the 16th should equal. Oh, it's the same. Okay, so it is A. All right, so you can expand it out this way, or know that you just add 4. This is the same as 8 to the 4 plus 12. That was one of our rules. Number 4, which statement is not true? Okay, so you can always use your calculators to figure this out, okay? But if you're using the rules here, 4 to the 9 times 4 to the 3rd means you add them, not multiply. So it's not A. Oh, and this one's saying not true, so it must be A. Okay, I have to pay attention to words like that. Let's see here. Yeah, 3 times 5 is going to give you 15, so that's right. This is true. We're looking for the one that's not true. Okay, now this one is actually going to be 7 to the positive 3. Okay, so this is not correct. And then this one is correct. Wait, hold on. Oh, that is correct. Okay, because there's a long story to that. But if you do 7 to the 12th divided by 7 to the 15th, you get 2.9, and then to the negative 3. Now let's see. 7 to the negative, will 7 to the negative 3 give us that same answer? Yes. So this is true. Now this is also true because when you have a negative exponent, it flips to the bottom, but this is not true. So 4 is A. Okay, number 5. Remember, negative exponents go to the bottom. Okay, now when you go to the bottom, that means it's not negative. Okay, it's not going to be a whole integer. So now think about what this actually means. Do not say 18. This is a trap. Okay, 6 times 6 is already 36, way bigger than 18. Multiply that by another 6, it's going to be 216. Number 7, okay, so what you have here is these multiply, so it's going to be 3 to the 6th over 3 to the 5th. Okay, when you divide the same base, you subtract exponents, or I'm going to write it out. 1, 2, 3, 4, 5, 6. Multiply, multiply, multiply. 1, 2, 3, 4, 5. Cancel, 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 cancel. This is 3 over 1, which is just 3. That's a trap. Putting 1 over 3. All right, number 7. Number 7, which expression shows 0.61 times 10 to the 12th power expressed in proper? Okay, so we'll talk about this one in class, okay? And we'll do that in class for sure. Number 8, same thing. We have to talk about what proper means, and I wasn't going to be able to do that until tomorrow. Okay, now this one we should be able to do. So which expression shows 20,010,000 in scientific notation? Well, make sure the decimal's in the right place. Now this one is a little different than what we did in class because there's a 2 here and a 1 here. You can't have a gap, so you're going to have to close in on 2, 0, 0, 1. Okay, so if I think about 2, 0, 0, I'm going to leave the commas out because that could be confusing. 2, then 2 zeros, then 1, and then 4 zeros. 1, 2, 3, 4. Okay. Now, I know the decimal needs to be somewhere in here. Is it going to be before, or after, or after, or after, or after? Well, it needs to be so that the number to the left of it is between 1 and 9. So there it is. So now, if it's 2.001 times 10 to the, then which way does it have to go? 1, 2, 3, 4, 5, 6, 7. 7 to the right. So it can't, so it's 2.001 times 10 to the, not a negative, so that's out. This one didn't go quite far enough, and this one ignored the 0.001, so D. Number 10, okay, so let's write this again without the comma. 732000000. Okay, the decimal needs to be somewhere in here, so it's going to be right here. So I'm going to write 7.32 times 10 to the 1, 2, 3, 4, 5, 6, 7, positive. So it has to be this one. Okay. Now this one doesn't even count because that's not doesn't even have the right decimal in the right place. Number 11. Okay. So this one says, according to the Bohr model, the radius of a hydrogen atom is approximately this many meters. What is the number expressed in standard form? So standard means all the zeros. Now, which way does this negative 11 tell you to go? To the left. So 5.29, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now be careful because just one too many zeros or one short zero is going to throw you off. So it might help 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure you have a 0 for all the empty spaces. This is where the decimal ends up. So how many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Okay. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Too many zeros. And then these are too big, so it has to be A. The radius of the Earth is approximately 6,370 kilometers. What is the distance in scientific notation? Okay, so let's think about this. I want to look at this. Where does the decimal need to be? Right here. So 6.37, I don't need the 0, times 10 to the 1, 2, 3. So it's not negative. Okay, this is not even the right place. Okay, so it's one of these. It has to be that. So it's C. This is the end of the video.